Hello everyone. In this video, we're going to be solving an exponential equation. So we have the following equation, and notice that the left-hand side uses parentheses while the right-hand side doesn't. So let's just note that if we have an expression like a to the power b to the power c, then it can be written as a to the power bc. But if we have it without the parentheses, it's usually understood as a to the power b to the power c, where b to the power c is grouped together. So that's what we're going to use here to solve this problem. We're going to be looking for real solutions. Are there any complex solutions? I'm pretty sure you'll let me know. So let's go ahead and use the rule for the power of a power. In this case, it would be x to the power x times x, which is x squared. And that equals x to the power x to the power x. Let's go ahead and ln both sides. And ln is the natural logarithm here. If we ln both sides, we get ln x to the power x squared equals ln x to the power x to the power x. And by using the properties of logarithms, we're going to go ahead and move these exponents. This is an exponent, this is another exponent. And if you move them, obviously in this case, you kind of have to be careful about the domain, and we'll talk about that a little later. So let's move the x squared to the front. That gives us x squared times ln x. And then this one gives us x to the power x times ln x. Now don't cancel out the ln x because you might be losing some solutions. So instead, let's just go ahead and put everything on the same side and factor. So ln x is a common factor, so I'll take it out. And this is going to give me x squared minus x to the power x equals 0. Again, here I'm assuming that x is always positive, but I'm also going to be looking at the negative solutions. From here we get two results. ln x equals 0, which means x equals 1. So we're going to check if that works. And then the other one gives us x squared equals x to the power x. So if you plug in x equals 1, obviously it's going to work. So that's a valid solution. But what about the second one? X squared equals x to the power x. I know some of you are saying, obviously, x needs to be equal to 2. But let's ln both sides again, just for the fun of it. And if you ln both sides, you get ln x squared equals ln x to the power x. And moving the powers again, we get 2 ln x equals x ln x. And as before, we can take out the ln x and write this as 2 minus x equals 0. So from here, we get two solutions. ln x equals 0, which is something that we had before, x equals 1. And then from here, we get x equals 2. And that was kind of obvious, right? When you saw this equation, you immediately said, probably, most of you, maybe all of you, x equals 2. Okay, great. So far we got two solutions, x equals 1 and x equals 2. And I would like to check if x equals 2 works as well, because we did a lot of lning, and what if it doesn't satisfy the original domain? Okay, so I have x to the power x squared equals x to the power x. If x is equal to 2, this gives us 2 to the 4th equals... Oh, by the way, I forgot the other x here, right there. Okay, so this gives me 2 to the 4th equals 2 to the 4th. Therefore, x equals 2 works. Great. So that is a valid solution. So far, we got two solutions, x equals 1 and x equals 2. Are there any negative solutions? So we're going to be looking at the graph, and then I'll go back and forth to check for the negative solution. All right, let's go ahead and take a look at the graph. I graphed both of these functions for you. And you can also see the results from Wolfram alpha, so that kind of gives away the solution, but that's okay. Notice that I graphed y equals x to the power x squared along with y equals x to the power x to the power x, kind of like an exponential tower with 3 x's. And notice that they intersect at 1, 1. Not only they intersect, but they're also tangent. So if you go ahead and differentiate both of these functions and evaluate the slope of the tangent line at 1, 1, you'll notice that it is the same tangent line. So that means these curves are tangent. So 1 is definitely a valid solution. What about x equals 2? You don't see that in the graph, but you see it in the Wolfram alpha's graph, because that's kind of like a little bit of distorted. If you use the same scale for x and y, obviously you don't get to see the graph because that's going to be too tall. But if you look at the graph on the left-hand side, it also shows you that we have a solution, a point at 2, 16, and intersection point at 2, 16, which means x equals 2 is another valid solution. What about the negative solution? Where does that come from, right? X equals -1 seems to be a solution according to Wolfram alpha, but we don't see it on the graph because the problem with the graph is the functions are not well defined for negative x values. You know, when you have a negative base and an exponent that is fractional, like 1/2. For example, what is -1 to the power 1/2? What is -1 to the power 2/4? So that's very problematic. You know, you kind of get into the complex arena. But if you look at this expression, why does -1 works? Because when you have something like x to the power m equals x to the power n, and if x is equal to -1, m and n have to both be odd, right? So in this case, we kind of get -1 to the power 1, and that is -1 to the power -1 to the power -1. And -1 to the power -1 is just the reciprocal of -1. It is -1, and obviously -1 to the first power is the same as -1 to the power -1, because the reciprocal of -1 is also -1. So this basically tells us that there is going to be 3 solutions to this equation, and those solutions are -1, 1, and 2. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.